Hello and welcome. My name is Eamon Killian and this is tutorial number 6, part 1 of a series I'm doing on how to get started using IBM software. So in the previous tutorials I've done an awful lot of work around virtual machines, how you actually get started, registered with software, how you use the software customer portal, how you can then set up virtual machines, start an Apache web server, etc. But it was very focused on using the virtual machine. This tutorial is going to move on to storage, and in particular object storage. As you can see here, we're going to actually go through a sequence of how to create some object storage, and we're going to get really stuck into that in part 2. Based on some feedback I've had, I thought it'd be worthwhile adding a little bit of an intro around what object storage is, and then describe what we're actually going to be doing in part 2 and possibly part 3 after that, depending on how long these videos get. So this is by no means the soup to nuts introduction on what object storage is, but it's meant as a very high level what it is and then really what you would use it for. So storage in general, at a very high level, your computer has a spinning disk in it, whether that's a server or a desktop computer, a Mac, a laptop. It's probably going to have a hard disk of some kind, which is going to have a spinning series of disks in it, which is where ones and zeros are imprinted on that using magnetism. Essentially, it's very physical, and it's a physical piece of hard disk, as it says, or hard drive. Some people call it disk drive. These days you can get flash drives, which are slightly different, but the principle remains. It's ones and zeros on a piece of physical hardware. That is then organized into a series of blocks of data, and those blocks of data can be represented within the operating system to make it human readable as actual files. And then those files are organized into file systems. So what we would all see, maybe if we're using Windows or Finder in Mac, you'll have a series of folders with subfolders, and that's where you would put your files, and you can organize your files. And that's a really handy way of interacting with your computer, and makes it much more easy for us as human beings to actually use the computer, because dealing with long strings of ones and zeros would be nigh on impossible for us. Object storage takes a different approach to the traditional file system approach, and that different approach revolves around actually taking the file, but wouldn't it be nice if we could actually get the description of the file and much more information about the file, rather than in our traditional view of just having the file name. I guess arguably you get a little bit more than the file name. You get the file name, the creation date, the modified date, etc. But wouldn't it be much better if we could actually have notes and information and data about the file that would really describe what the file is, and we could approach or search that information to find the file much more easily. And that's essentially what it does. So it creates an object. It converts the file by taking the file here and adding metadata and creating an object. So our white here is the object. And then once it's got the metadata in the file, it can then calculate an actual hash checksum of the file. So without getting too deep on this, the hash is a mathematical function that returns a single big number, as you can see here. And that single big number is based on the two of these. So you input the two of these, the file, all its contents, and the actual metadata, and you get returned to you a checksum. Now, that's really useful because the checksum provides us with integrity. So it means we can know when anything changes in the metadata or the file. We can actually know this because when we run that same mathematical function, you won't get this number. This will be unique to the interaction, to the contents of those. And when you run it, it's highly unlikely. I mean, you can have collisions, as they call them, but highly unlikely that you'll get the same number again. That now means this object is both self-describing with the metadata, and we have rudimentary integrity of our file system, of our objects. So we can detect when anything changes, or we can detect corruption. So this is an object. We can have other objects. So here's an invoice with a different checksum, and so on. So you can have many, many objects. So that's the first thing, the object. Because we now have self-describing objects, we can set up an object storage platform, and we can tell it to copy those objects. So we can now have multiple copies of the same object stored on different hard drives, so that if the hard drive fails, we always have a copy of it. Or if it gets corrupted or deleted by accident, we always have a copy of it. So in this instance, there's 2 more copies here. Taking that a step further with an object storage platform, everything is stored in a massive flat view. So all the objects just get thrown into essentially what they call a container, and this can be of infinite size. There's bound to be an upper limit from a physical hardware point of view and a computing point of view, but let's use the word infinite. It's going to be huge. And that will be some storage hooked on to cheap storage, hooked on to some processors, and those processors will use some software on top which will present that element or that container out to the end user. So that's really handy. So what happens then if it starts to fill up? Well, because of the configuration and the way we've made the object storage platform, as it fills up, we can hit a threshold and add some more. We can simply add some more cheap processors, the same software to manage the object storage platform, and more cheap disk. And as that fills up, we can hit a threshold and we can add some more. This is what gives us this almost infinite or near infinite size. It's a flat container, but it's now being spread across these multiple nodes. So you would call each of these a node within the object storage cluster. So you just add more nodes and you just keep going. And this can be billions of files, petabytes of data. I mean, it can get really, really huge. So now we've got that, mixing those two together with the integrity that we talked about before and the checksums. What would be really interesting is you could actually position your object storage nodes to start being created geographically. And you can spread out the copies of your actual files, your objects, within different nodes in different data centers in different geographic locales. And this gives you, integrity from corruption, deletion, disaster recovery. There's no reason why it should be in the same country. So the final word on this is we can now have, as I mentioned, integrity and redundancy by distributing our objects across the world. I should draw your attention to, look, this isn't how SoftLayer's default configuration works, but this is just object storage. This is how it could work if you set the configuration up to do this. The default configuration from SoftLayer, which we'll show in a second, is multiple copies within the same cluster in the same data center. So that's a very high level introduction on what object storage is. But okay, so what's it used for? What's the use cases, as they call them? Why is this useful? Well, object storage, because of that infinite scale and billions of files in a flat structure, but with metadata that's searchable, it means it's really handy for very large media files, photos, web content. Absolutely super for web content. If you wanted to create your own version of YouTube, an object storage would be fabulous. Massive scale documents, so for document distribution, spreadsheets, PowerPoints, PDFs, backups, and making archives. It's absolutely fantastic platform. Object storage is wonderful for all of these things. And even going beyond that, it's great for databases. Not relational databases, that's one of the use cases that doesn't work well with object storage, but having NoSQL, like a MongoDB database, perfect. Sensor data, if you have lots of security cameras around a building, then having an object storage at the back end to take those images and videos, or sensor data such as the door open, the door closed in machine-to-machine world, fabulous for that. Log files, chat files, and finally blogs. So it's really, really useful because of this scale and because of this near infinite capability and the flatness and the self-describing. So what are we going to cover today? Well, today we're going to go through creating a new virtual machine. So here's our little virtual machine here on SoftLayer. I'm going to use CentOS again because it's just what I'm used to. We're going to create some new object storage, and then we're going to link our CentOS virtual machine to that object storage so that we can actually see the object storage cluster from our virtual machine. And we're going to use CloudFuse to do this. And then finally, I'm going to link CyberDuck and FileZilla into that object storage as well. And we'll see how we can upload some files using CyberDuck, and then you'll be able to see them from the server. A very quick introduction to what object storage is and what we're going to be doing today. So join me in part 2 and let's dive into actually creating some stuff here.